Most students lose points on system of equations because they pick the wrong method to solve. Today, we'll review graphing, substitution, and elimination step by step so you're ready for your unit test. Let's get started. The first few questions you will get on your test will be all about solving system of equations by graphing. So let's take a look at this first example. It does say here it's one solution. That's just a hint. But how do you know if it's one solution? Let's get that out of the way. As you can see here, we have our slope, which will be right here, the 2, and then over here it's -1, are different. And as well as our y-intercepts, this is where the line is crossing the y-axis, are different as well. So as you can see, they're both different, and that's what makes it one solution. Now, I want to warn you that sometimes, even if the y-intercept is the same, the only thing that makes it one solution is when the slopes are different. So for example, if let's say the y-intercept is the same, so I'm going to draw this out for you so you can see very clearly. Let's say the y-intercept is 5. Well, that's okay for both of them because that will be their solution, right? 0 and 5, let's say. And this is where they're going to cross, and therefore it's one solution. So the most important thing for you to look for is to see, are the slopes different? As soon as the slopes are different, that makes it one solution. Okay, so that's out of the way, and now let's learn how to graph. The first thing that you need to know that these two equations are written in a y-intercept form, which means y equals mx plus b, and we'll figure out which one is m, which one is b. So m is our slope, which means that we're going to graph it as such: rise, which will go upwards, and then run will go towards side. I always go towards right, and I will explain it as we go. So b is our y-intercept, and that means this is the starting point. So remember, this is where we start, because that's the first point that we can put on a graph. So I'm just going to create a little graph here. I think we have to go all the way up to 4, which is fine. And let's go ahead and put our points, 1, 2, 3, 4, and then do the same on this side. Okay, so let's start with the first equation, y equals 2x, okay, plus 1. Like I said before, we're going to start with b, which is our y-intercept. That's the first point we can put on the graph. So that would be right here, 1, right? So the first point in here is 1. Right, that's great. And then from this point on, we can go ahead and rise and run to our slope, rise and run, and then figure out where's our next point going to be. So our slope here is 2. So 2 as a fraction will be 2 over 1. So we're going to rise 2, and then we're going to run 1. And so let's go ahead and do that. So we're going to rise, we're going to do an arrow here, rise 2, 1, 2, and then run 1. And then I'll put an arrow in here as well, run 1. And our point will be, the next point will be here. And you can do this over and over since the slope is constant, right? And so let's go ahead and do it maybe one more time. I'm going to draw one more here. 2, and so we have 1, 2, and then one more here. All right, so let's go ahead and do that. From this point, we're going to rise 2 again, 1, 2, right? And then 1 to the side. Okay, so our next point, so I'm going to put a little bit of dot in here so you can clearly see where is our next point. Okay, so let's go ahead and use our ruler and draw that line out. And so this line actually wanted to be a blue. Okay, and so this is our first line. Okay, so that was our first equation. Let's go ahead and try our second equation. I'm going to use a different color. So the second equation, as you can see, y equals -x plus 4. And this could be confusing. I use this example. It's very important because you should know that negative x will mean -1 times x, but we don't write 1 because there's just one x. It's given. So the slope in here will be 1 over 1, and it will be negative, don't forget. And we're going to rise and then run, okay? And our starting point will be our y-intercept, which is 4. So let's go ahead and do that. So we're going to go up 1, 2, 3, 4. Okay, and then that's our starting point. And then from here, we're going to rise 1 and run 1. Now, notice that this is a negative slope. So I'm going to erase the previous things. Give me a sec. Okay, we're back. So notice that it's negative. So what I usually do, if it's negative slope, I will go down 1, okay, and then 1 to the side, and that's where we are. So let's go ahead and put the dots so you can see where we are. Okay, so let's try that again. And we can see their crossing point. Again, down 1 and 1 to the side will be our next one. As you can see, I went down for negative slope to the right, and for positive slope, I went up and to the right. So if you use this system, it will be much easier for you to graph any kind of equations, linear equations. Here we are, and we can see where they're crossing. Remember, the crossing point is our solution. So let's go ahead and write the solution here. And what is that crossing point? So we have 1, right, for x-axis. Remember, the x-axis goes first, and 2 for the y-axis. And that is our solution. Let's go ahead and try our second one. All right, so let's take a look at our second example. It does say no solution. From our previous example, we know that when the slope and y-intercepts were different, that made it one solution. And we also talked about that the y-intercept could be the same. Now here you can see that our slopes are the same. If the slope is the same, and that makes it no solution. Remember that y-intercept has to be different. All right, so it's very important that y-intercept is different, but the slopes are the same. And this is something that I've brought up before, that imagine that you're walking with someone and you started from different locations and you're walking at the same pace, hence the pace of, like, let's say 3 minutes per, I don't know, 100 feet. And so if you're walking at the same pace, there's no way you're going to catch up to each other, and there's no way you're going to meet somewhere. So that's what this means. Okay, so let's graph these equations. Okay, let's draw our graph out. Okay, the highest point will be, so 1, 2, 3, 4, 5. Let's go ahead and do that on the other side. 1, 2, 3, 4, 5. Okay, so remember, this is our x-axis and this is our y-axis. I'm going to write our first equation, which will be y equals 3x minus 2. Again, we're identifying our slope and y-intercept. So our slope is 3, which will be 3 over 1. So we're going to rise 3 and then run 1. And then our y-intercept is 2, which will be our starting point, right? That's the point that we actually can graph right away, start from our y-intercept. Okay, let's go ahead and do that. So we're going to go at -2. Oh, yeah, I have to, give me 1 second. Let's continue this, and 1 and 2. Okay, so we have a -2. See, there, I didn't even notice that. So we're starting our first point at -2. Very good. And then our rise is 3. So we're going to rise 3, and I'm gonna put dots 1, 2, and 2 at 0, and then 3 right here, and then 1 to the side. That is our second point. Okay, so let's go ahead and do that again. So 1, 1, 2, and 3, and then 1 to the side. There you are. Okay, from here I can actually draw our lines. Usually 3 points should do it. And let's go ahead and write the second equation. I'm going to write it in the bottom. So our second equation is y equals 3x plus 1. As you notice, the slope is the same, but we're starting at 1. So the slope is 3 over 1. And then y-intercept, our starting point, is 1 as well. So again, I'm going to highlight this part that you start with a point that's given to you. So right over here, that is our first point. Now 3 over 1, again, we're going to go up 3, 1, 2, 3, and then 1 to the side. That's our second one. That's our second one. And then let's do one more. I need to add one more here and another. Okay, so let's go ahead and do that. 1, 2, so go ahead from here, 1, 2, 3. So I'm going to put the points, and then 1 to the side, which is all the way over here. Okay, so let's make sure that I'm in the right place. Yeah, right over there. Okay, as you can see, I forgot that I was using the red color. That is our third one. As you can see, the lines are not meeting. There's no solution. There's no crossing. So here we're going to say no solution because the lines do not cross to give us a solution for both equations. In our third example, things are not written in a y-intercept form. In fact, only the first equation is written in a y-intercept form, but the second one is not. So what do? We have to either rewrite it in a y-intercept form and then graph it, or we can find the y-intercept and then the x-intercept when we solve for y or x. Now the easiest thing over here, I can clearly see I can rewrite it in a y-intercept form, and that will be the easiest thing to do. So let's go ahead and do that. We're going to start with our second equation, rewriting it. So 2y equals negative 4x plus 10. I do want to remind you again that we're looking for the y-intercept form, which will be y equals mx plus b. As you can see that the y is on its own, it's 1 times y. So what do? Y is not on its own. We have to solve for y, therefore we divide everything by 2. Okay, so that will be 1. Y equals negative 2x plus 5. Okay, so our equation is written in a y-intercept form. As you can see, that was very easy. And now we can start graphing. So we have to go all the way up to 5, and there's no negative y-intercept. So let's go ahead and write it like that. So 1, 2, 3, 4, 5, 6, 8, 9, and 10. I'm going to go one more up here. Just a little bit more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, same here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, hopefully I made equal. Okay, so let's graph the first one. As you remember from previous one, I'm going to start with my y-intercept. And that means our first point will be starting at 5. 1, 2, 3, 4, 5. That's exactly where we start. That's our first point. Now we're going to go to our slope, which says it's -2, which means -2/1. We're rewriting it as a fraction so we can do our rise and run. As you remember, we have to go down for this one because it's negative and towards right. So let's go ahead and do that. We're going to go down 2. So 1 and then 2 and then 1 to the side. 1 to the side, and that is our next one. And then let's go ahead and do one more. We're going to go down 2 and 1 to the side, and that is our third point. And having 3 points will make it easy for us to graph unless we're going to need another one. So let's see if we're going to need another one. Okay, so our first equation is plotted, and then let's go ahead and plot our second equation. Our second equation is y equals -2x plus 5. What do you notice about these two equations? I'm just going to start plotting and you think about what do you notice. Is there something that they're the same and some they're different, or everything is the same? Okay, so we're going to again start with our 5. And then our slope is 2/1. And don't forget it's negative. That means we're going to go down 2 and right 1. And so we end up in the same place. What do you notice? Do you notice that these two equations are the same? Also notice that we wrote infinitely many solutions. So when the y-intercept and the slope are the same, that means we have infinitely many solutions because their solutions, they're going to cross at every single point and they'll have the same solutions. So let's go ahead and write that the slope same, and then y-intercept same. All right, so let's recap here. What makes it one solution when the slopes are different? And it doesn't really matter if the y-intercepts are the same or different. When we have no solution, we have the y-intercepts has to be different and the slope must be the same, as you can see. And for infinitely many solutions, the slope and the y-intercept has to be the same in order for it to be infinitely many solutions. Here's part 2, solving by substitution. And what does that mean? That means we're going to substitute one of the variables with whatever answer we have. I have 2 examples here where the one we're isolated, when we have an isolated variable, and one that the variable is not isolated and you have to work with. So imagine you will get this easier questions and harder questions. I want to make sure that you're really prepared for everything that your teacher will give you. Okay, so for the first one, let's rewrite the equation. It says x equals 5 minus y. As you can see, the variable is isolated, so that makes it a bit easier to solve. Okay, from here, I can see that x is already solved, so I can substitute x. And that's how I make a decision. Will I be able to solve for x? Yeah, x is already known. It's 5 minus y. So I can substitute x in the second equation. And let's go ahead and do that. So instead of writing x, I'm going to write 2 times 5 minus y. And then I'm going to rewrite everything else the same. All right, now we're going to distribute. And what does this mean? It means that 2 is multiplied with 5, and then 2 is multiplied with y. Okay, so we're going to multiply. 2 times 5 is 10. Negative 2 times y is negative 2y, plus y equals 10. And now we're going to combine the y's, negative 2y plus y. Okay, negative 2y plus y will equal negative y. So 10 minus y equals 10. And then let's go ahead and subtract. And this means we're doing inverse operation because 10 is positive from both sides. Subtract 10 from both sides. And so negative y will equal 0. And since it's negative y, we have to make sure that we're dividing with negative 1. And that will make it y equals 0. Okay, so what do we do right now? We substituted the variable that was isolated. And now we have to find what is y. And that's the whole process, right? Finding the answers for both variables. So let's go ahead and write this ordered pair. This means this is where they're going to intercept. So our y is 0. So we're going to look for x. To find x, we're going to substitute our y, which equaled 0. Okay, so let's go ahead and do that. X equals 5 minus 0. So instead of writing y, I said 0. So then x is 5. So imagine they're going to meet, the two lines are going to cross at the point of 5 and 0. All right, let's go ahead and do our second example. Well, let's write the solution here. All right, so on our second example, as you can see, none of the variables are isolated, which means we have to solve for one in order to find the answer. Here to solve for the second equation, to solve for x, and the only thing that we're doing here is just go ahead and move the y to the other side. That means adding y to both sides, and then basically rewriting the equation as x equals 1 plus y, and that's it. Okay, so I'm going to rewrite it here as well, so you can see x equals 1 plus y. Okay, now what we're doing is we're going to rewrite the second equation. 2x plus y equals 11. And we already have the x solved, so we're going to basically substitute x, which is 1 plus y, right in here again. All right, so that means 2 times 1 plus y, and then plus y equals 11. Okay, again, what we're doing is distribution. Okay, so that means 2 times 1 and 2 times y. So that's going to be 2 plus 2y plus y equals 11. And then we're going to combine. That means 2y plus y, which will be 3y. And now we're going to move our constant to the other side by subtraction. So 3y will equal 9. All right, so the last step is to divide by 3. And so our y equals 3. So let's go ahead and write that down. And we're looking for x. X is still unknown. And to find the X, we have to substitute the Y in the equation. By the way, you can substitute in any of the equations. It really does not matter. But you're always looking which equation would be easier for me to solve. So I guess this one will be easier. 1 plus 3, and so X equals 4. And there you are. That is our solution. 4, 3. And that's where they were intersect. And this is substitution. Solving by elimination means that we're going to eliminate one of the variables to solve for one variable, and then we're going to substitute the variable to solve for the other. That means we're looking for X and Y values by elimination. So let's go ahead and start with our first one. And as you can see, I have 4 examples in here, and those are the 4 different types of examples you will encounter in your test. The 4th being the hardest one. It's possible for it to be a bonus questions. I would usually put this as a bonus question for my students. The first example is X plus Y equals 8, and then X minus Y equals 2. As you can see here, we can add the equations to eliminate one of the variables. Can you guess which variable we can eliminate by addition? So let's go ahead and add. So we're adding every single term of both equations, hence I wrote it on top of each other. So this will be 2x, and then y minus y will be 0. As you can see, we've eliminated y, and 8 plus 2 equals 10. Now we're going to solve for x, and that will equal 5. We're looking for x values and y values. So x is 5. Now let's go ahead and find what is y. To do that, we just have to substitute x in one of the equations. And the question is, does it matter which equation? No, it doesn't. So because it's a solution for both equations. Okay, so since we said that x is 5, I'm going to write 5 instead of x. And then we're going to solve for y by subtracting 5. And all we're doing is isolating y. And so y equals 3. And there you have it. We found x and y, and so our solution will be 5, 3. Let's go ahead and write that in here. Solution. And it's 5, 3. Let's start for our second example. Okay, so our example 2, here it says, well, maybe we need to, instead of adding, we subtract. And when do we do that? We do that when we have the same, we can eliminate the y's in here, as you can see, but they have the same sign. So if we add, y plus y will equal 2y. So that's not going to help us at all. So therefore, we have to subtract. So let's go ahead and write these 2 equations. And then minus 4x minus 2x will be 2x, and then y minus y will be 0, and then 17 minus 11 will be 6. So let's go ahead and divide both sides by 2 to solve for x. And so x equals 3. Let's go ahead and write that down. X equals 3, and now we're looking for y. And to do that, we're going to substitute x in any of the equations. I would say that I'm going to substitute it in a second equation. It seems a bit easier, smaller numbers. So instead of writing x, I'm going to say 3. So therefore, 2 times 3 minus y equals 11. And that will be 6 minus y equals 11. We're going to subtract 6 from both sides. And so negative y equals 5. Let's go ahead and make this just a bit smaller so I have more space to work. And you can see that we can't stop here. We have to divide both sides with -1 since it's negative y, which means -1 times y. And so therefore y will be -5. All right, we found our y and our solution is x is 3 and then y is -5. So 3 comma -5. So let's go ahead and write our solution. 3 comma -5. Our third equation is another way of solving by multiplying one of the equations by a number. So what causes this issue? Well, the first thing that you have to see that we cannot eliminate any of the x's or the y's. Therefore, we have to kind of manipulate one of the equations or both equations to do that. So I can manipulate the first equation. If I multiply by 2, as you can imagine, I can subtract then both equations and then eliminate the x's, because 2 times 2 is 4x, and I can easily eliminate the x's. So let's go ahead and do that. The only other thing that you can do, if you don't want to subtract, you can actually multiply with -2, but that makes it just a little bit harder for you to do. So let's go ahead and write our first equation. So it's 2x, I'll change the color. So 2x plus 3y equals 13. And let's not forget we're looking for x and y values first. I'm going to multiply this by 2, the entire equation. And so that will be 4x plus, remember, everything will be multiplied. So 2 times 3y will be 6y, and then 2 times 13 will be 26. Okay, done that. So we multiplied by 2, and now we can rewrite the second equation, which will be 4x plus 5y equals 23. And now here you can determine, am I adding or subtracting? Here I can see that if I add 4x plus 4x will be 8x, so that's not going to help. And so if I subtract, right, and that will make it easier. So let's go ahead and subtract. Okay, so I can subtract 4x minus 4x will be 0. 6y minus 5y will be y. So then 26 minus 23 will equal 3. Okay, that means we solve for y, and y equals 3. Let's substitute y in any of the equations. I can start with, we can start with the first equation, 3y equals 13. Let's substitute y, and y is equaling 3. So that will be 2x plus 3 times 3 equals 13. So that will be 2x plus 9 equals 13. Now let's go ahead and subtract 9 from both sides. And so it will be 2x equals 4. Let's divide both sides by 2. And so then x will equal 2. So we found both, x equals 2. So our solution is 2 and comma 3. So let's go ahead and write the solution. That will be 2 comma 3. For our third equations, as you can see, we cannot eliminate the x's or y's, and so we have to make that decision. What do we do? It says multiply both equations by a number, and which means like, okay, we have to decide which one should we eliminate. And you make this decision by thinking about, well, which one will be basically easier to eliminate. I can see that the y's are a little bit easier, because if I get both of them to be 6, then I can eliminate the y's. And how do I do that? Well, if I multiply 2 by 3, right? and that will be 6. And then if I multiply 3 by 2, and that will be 6 as well. So that's the easiest one to do. So let's go ahead and do that in here. So basically, we're going to multiply both equations at this point by different numbers. Okay, so the first one, let's go ahead and write that we're going to multiply by 3. And then the second one, we're going to multiply by 2. So I'm going to rewrite the second one as well. Okay, so and then this one we're going to multiply by 2. So let's start with the first one. When I say we're going to multiply by 3, that means each term will be multiplied by 3. So let's go ahead and do that. Change the color. So 3 times 3x will equal 9x. So 3 times 2y will be 6y. And then 3 times 12 will be 36. All right, so that's the first one, and let's go ahead and do that. 2 times 5x will be 10x. 2 times 3y will be 6y. And 2 times 19 will be 38. Okay, now that we have this set, and we have to decide, do we add or subtract? As you can see, if we add 6y to 6y, it will be 12y. So we do have to subtract both equations. Let's go ahead and do that. I'm going to write subtract right there. And let's do that. So 9x minus 10x will be negative x. And then 6y minus 6y will be 0. Equals 36 minus 38 will be negative 2. Okay, so we're going to divide both sides by negative 1, and then x will equal 2. Okay, we found our x. Let's go ahead and find our y by substituting x. And I can substitute it on any of the equations. I'm going to try the first one. And you make this decision on your own, which one should I choose, and both will be exactly the same. So we said that x equals 2, and that means we're going to write, instead of x, 2. So that means 3 times 2 plus 2y equals 12. And so that will be 6 plus 2y equals 12. We're going to subtract 6 from both sides. I'm going to rewrite everything here. And so that will equal 2y equals 6. Divide both by 2. And so then the y will equal 3. Okay, so we found our y, and our solution is 2, 3. Okay, this is pretty much everything that you're going to encounter for your test for elimination. The first thing that you have to answer the question is, am I eliminating by adding or subtracting? And as you remember, we added when the signs were different. We subtracted when the signs were the same. Then the next one is, am I going to manipulate one of the equations or both equations and multiply one equation by a number to eliminate one of the variables? In here, as you remember, we multiplied the whole equation by 2 in order to eliminate the x's. And on our fourth example, we multiplied both equations, the first one by 3 and the second one by 2. After we did this multiplication, we had to decide, do we add to eliminate or subtract to eliminate? And these steps are very easy to remember. Basically adding, am I adding or subtracting? Am I multiplying? And then the second step will be again going back to, am I adding or subtracting to eliminate one of the variables? Well, thank you for watching. If this video was helpful, please subscribe to the channel for more videos like this. And remember, learning math takes patience, practice, and perseverance. See you on the next one.